Hi ladies and gentlemen, this is another in my series of lessons for Algebra 2. What we're looking at today is Unit 2, Lesson number 11. This is the application of logarithms, okay? Logarithmic functions are pretty prevalent in the science fields, okay? I can go through almost any science field and find an application of a logarithmic function that you would be using, okay? I've picked a few out, just a few. Most of these problems are very long to work. I will work some more in Class Connect with you guys. Okay? Let's start with the chemistry one. In chemistry, if you're trying to find the pH of a substance, there is a function that actually models it right there. Okay? The pH of a function is found by taking the negative log base 10 of x. Okay? Where x is the um, let's see, what is X? X is the pH, okay? Where it says H plus, but I mean H plus is the hydrogen ion concentration of the substance measured in moles per liter, okay? And so we're wanting to find the pH of this particular apple juice. It's 3.5. So I'm just going to replace X with 3.5. I've got negative log 10 of 3.5. You know what? I think that one is simply a matter of keying it into the calculator and doing it. Okay, so let's get rid of what's here. Okay, so it's log 10, so that means I can do it on my calculator here, right? So I'm going to clear this and say negative log 10 of 3.5 and hit enter on that, and I get a negative 5.544. That's what I would list as the pH. Okay? And it's just a factor of using whatever equation they give you and how they give it to you to come up with the value. Let's see here. You know what? I just worked that problem wrong. I'm going to erase it because they're not giving me the H plus. They're wanting to know what the hydrogen level there is. They gave me the pH. Sorry, working a problem wrong in one of these things is not what I want to do. That's supposed to be 3.5 is equal to negative log 10 of x. And we're trying to find what x is, that h plus. That's what we're trying to find at this point. Well, seeing this negative sign, I'm going to divide the other side by it, and I'm going to get negative 3.5 is equal to log 10x. Okay? Now we can convert this to exponential form. That's 10 to the negative 3.5 is equal to x. Okay? Well, that's something we can do on the calculator too. That's 10 raised to the negative 3.5. And what do we get when we do that? Let's get rid of that parenthesis. We didn't need it. We get 3.16. And so my x, my h plus in this situation, which is what they were looking for, was 3.16 times 10 to the negative times 10 to the negative fourth. Very, very, very small number. That's the number of hydrogen ion concentrations in moles per liter. Small number. Well, we're talking about a mole of a substance. It's not going to be very much. Cool? Okay, moving forward. This one gives you this function, b times 1/2 raised to the th. That's the amount of half-life of an item. Okay? So reading carefully, sample of 50 megagrams of titanium 99M is given to a patient during a medical test. If the radioactive substance decays to 2.8 milligrams after 25 hours, what is the first half-life of this substance? Okay? Okay, so what are we looking for here? Well, we're looking for that h. Is what we're actually looking for. Okay, we can use these values that they gave me, 2.8 and 50, to find the b. Oh, I'm sorry. The b is the number of milligrams of the substance. So we've got that too. So we've got b, we got 1/2, we got t, 25 hours. We're looking for h, and we know that the remaining amount out here is going to be 2.8. So what do we got? Let's see here. Write it all down. 2.8 is equal to 50 raised of a 1/2 raised to the t, 25 over h. That's what we know right there. Okay, well, I'm going to get rid of the 50 to begin with, just because 2.8 divided by 50 equals 1/2 raised to the 25 over h. Now, this right here, I can do that on a calculator. 2.8 divided by 50 gives me 0.056. 1/2 raised to the 25 over h. Now I'm going to write this in logarithmic form. Okay? Why? Because I got a base, I've got a power, and I've got a value. So I'm going to say the log of base 1/2 of 0.056 is equal to 25 over h. Okay? This is just a number. Okay? And how would I do this one? I'd do log 10.056 divided by log 1/2. So I'm going to do that on my calculator. Log of 0.056 parenthesis divided parenthesis, thank you, divided by log 0.5 parenthesis, and I get what? 4.158. That's here. 4.158 is equal to 25 over h. So that means that h is going to be equal to 25 divided by 4.158. Okay, so I can actually do this. Let's see here. 25 divided by, recall that answer, and I get 6.011. H equals 6.011. So what is that telling me? Well, that's the H, remember? That's the half-life, okay? And since my T was in hours, this is going to be in hours too. 6 hours. 6.011 hours. That's what I would say the half-life of Titanium 99M. Cool? That's how you can work that out. Okay, one more. Carbon-14 has a half-life of 5,730 years. Archaeologists find a wooden bowl that has 40% of its normal carbon-14 levels. When you place B in the half-life formula with a 1, the formula becomes F of T is equal to 1/2 of T over H, and gives the percentage left after T years, where H is the half-life. So they're wanting to find out the age of the bowl. They're wanting to find T. Okay? So we actually know all the values here that we need. We're going to say that 0.4 is equal to 1/2 of T raised to the T over 5,730. Well, you know what? I can do logarithmic form here. So I've got log 1/2 of zero point 0.4 is equal to t divided by 5,730. That's easy enough to do. I can do over here log 10 of zero point 0.4 divided by log 0.5, and then multiply this whole thing by 5,730, and that will tell me what t is. I'm going to bring up my calculator here and move it over so I can see my numbers as I'm going, and I'm going to do a clear log 0.4 divided by log 0.5, and I get that number times 5,730, and I get 7,574. So t equals 7,534. So that's the number ahead. 7574. 75. 75. So years. How do I get years? Well, the unit to measure on this one was years, so the t had to be in years too. So that means that bowl that they found was 7,575 years old. Cool? Okay. Like I said, some of these problems take a little while to work, set up, make certain you're using the right right equation, but it's just using the logarithmic manipulations and the ability to take the inverse of it and go back to the um, exponential form. So if you have any problems with it, make certain you're coming to tutoring Tuesday, Wednesday, or Thursday. We are right at the end of the unit, so we will be doing a review in Class Connect. I look forward to seeing you there, and I will talk to you next time.